So we're going to do an example where we solve a limit numerically. And as we work through this, I'll talk more about what it is to even answer a limit question. So if you're going to solve a limit numerically, here is what the question will look like. It will say LIM for limit as x approaches 0. And then the function is here, whatever equation we're working with, which is sine of x over x. So what we're looking for is, what does this equal? What is the answer to this? So a limit is different than doing like an f of x question, a function question. So if this were a normal algebra problem without the limit involved, I might say, what is the answer of, if x equals 0, of sine of x over x? And you would just plug in 0. Well, I did that to show you that it doesn't work for a limit, because if you were to plug in 0, sine of 0 is 0, and you have 0 on the bottom. If you have 0 divided by 0, that is called an indeterminate form. And what that means is the limit has not been determined by just plugging in 0. What that means is at 0, we don't know what's going on, but a limit is not asking what's happening at 0, which is why we don't plug in 0. A limit is asking, what is the answer as it approaches 0? So we can't plug in 0, but we can plug in numbers close to 0. So I thought a number close to 0 would be 0.1 and negative 0.1. And then we have to approach 0. So a number a little closer to 0 is 0.01 and negative 0.01. Even closer is negative 0.001 and 0.001. You can get even closer with 0.0001, but with these three values, we should have enough information to answer the question. So what we're looking for is as x approaches 0. So as these numbers get closer and closer to 0, what is happening with these numbers? These are f of x values, these are y values, these are height values. So these are the numbers we're going to look at for the answer. So what I'm going to do is take my calculator and I'm going to plug in, you can see that, I'm going to plug in sine of, and I'm going to start, now I'll start over here, sine of negative 0.1, parenthesis, divided by negative 0.1. Can't really see that, but okay. So I just plugged in the x value for x in both x spots, and I got my answer. I'm going to go to as many decimal places as I can fit. So 0.9983, and then I'm out of room. Okay, I'm going to keep going. So now I'm going to plug in negative 0.01. What I use to do that is I go second entry, and then it gives me my old, question, and then I just go in and insert zeros to try to make it go quicker. It looks like 0.99998, so I'm going to write as much of that as I can. If you have more room, you should write more decimal places. Now I'm going to do second enter. Okay, I'm going to go over, I'm going to insert a 0. So now I'm plugging in negative 0.001. Got it. And that's more 9s. So point, and then lots of 9s. I can't fit them all. Okay, again, I can't plug in 0, so I can't do that one. But I can go and I can do this one. So I'm going to plug in positive 0.001, and I get negative 0.9999. Now I'm going to plug in, okay, nope, I messed up. Okay, hold on. That's supposed to be positive. I forgot to take out both negatives, so that is actually 0.9999. Now I'm going to go and plug in 0.01, and I got 0.99998, and then I'll plug in 0.1. It might seem like a lot of work, but all of this is required to find the answer to a limit, because what we're looking for is a direction. As you approach 0 from both sides, so from here, going forward, so as x approaches 0, These are the numbers that we came up with because that's a 0. We have to look at the y values or the heights and say, what are those approaching? And it looks like it started at 0.99, it went to 0.9999. Again, it looks like both of them are getting really, really close to 1. So my answer to my limit is 1. It's not plugging in 0, it's saying if I approach x equals 0 from both sides, but don't hit 0. But if I approach it, what are the answers, or the height of the graph, or the y values, what are those approaching? And if they're both approaching the same number, which these are both approaching 1, the answer is 1. If they're approaching different numbers, we cannot find a limit. The answer would be does not exist.